Hello YouTube. Today we're going to be looking at controllers, namely Web API controllers and MVC controllers. But even larger than that, or even more abstract than that, is the service interface layer and its roles and responsibilities. And towards showing you the roles and responsibilities of a service interface layer, I'm going to use the ASP.NET Core Web API controller. The same thing applies to the MVC controllers. And we'll also be talking about custom action results as part of this exercise, which is a feature in both .NET Framework as well as .NET Core Web API. So as you can see on the screen here, there's two boxes. One's called service interface layer and one's called the system. Now the system is how you want to see it. It's not anything to do with the Web API side. It is, let's say, a black box, or in this case a green box, that provides the functionality that you're trying to provide. In my case, I use a domain facade as the point of entry, if you will. And so for all intents and purposes, the domain facade is the system, as in you can't see past the domain facade from the outside, and so that's what you see is the system. Now the reason I'm calling it like the system is that's where you want to have all of the functionality you require to use, and that'll probably make more sense when I describe to you what a service interface layer is. Essentially, in terms of layer architecture, the service interface layer is the layer that allows you to interface with your system, whether it's through a user interface, maybe it's a web application, maybe it's a WinForms application or a console application, or maybe it's another service that's talking to your system, which is also a service publishing an API. The service interface layer is that interface. So when you build a system, you want to build a system in such a way that it's agnostic of how it is going to be used, in what context, in what environment it's going to be used. So that, for example, I mentioned there that the service interface layer could be an ASP.NET Web API application. It could be an ASP.NET MVC application. It could be a Web Forms application, a WCF application, a console application, a WinForms application, a Windows service application. This is the services that are part of the operating system. We can make those in C or in .NET, and anything else. So the system has all of the code, all of the logic required that accomplishes what that system is supposed to accomplish. The UI, the service interface layer, is the means or the mechanism with which you can interact with or interface with that system. So the way I see a web application, let's say a web API application, is simply a interface mechanism that allows your system to be talked to over HTTP and, let's say, JSON or REST or whatever, right? So you have a system and you want to expose that as a web API interface. So you create a new web API application and you interact with your system. And namely here we interact with controllers. So each of these service interface layers have a certain role or responsibility. So it's not just about the controllers, but I'm talking in terms of controllers because we use Web API quite a bit and MVC also quite a bit. So what are the roles and responsibilities of a service interface layer, or more specifically in this case, the Web API controllers or the MVC controllers? So the roles and responsibilities of a Web API controller are the following. On the way into your application, in this case from a HTTP request perspective, the controller's job, or the service interface layer's job, is to harvest the information from, in this case, that HTTP. So HTTP is sending all the data across the wire as strings, but you really want, or your system really wants, things like integers and floats and doubles and date times and custom complex types. So the job is of the service interface layer that's allowing the system to be interfaced with HTTP to convert that HTTP to C# and the types that we have in C#. So that's one responsibility, or one role or one purpose of the service interface layer in this case. The other is to then convert or strongly type the strings that we receive from over HTTP into these strongly typed C# types. And there are many times where the complex types that we have in the service interface layer are weaker, if you will, meaning they're not as strongly typed as the domain models. And we'll look at the code so you'll have a better understanding of what I'm saying here. So you have the notion of resource models that are in the SIL or in the service interface layer part of it, that are slightly loosely typed sometimes or most times. And then there's the domain model, which is in the system, that is more strongly typed. See, the system, the API of the system is a very strongly typed API. So it makes it easier to prevent bad data coming into the system. You may still have to validate things. For example, even though you got an int coming in, maybe the int is out of range, or you got a date time that's out of range, or you got an enum. But enums we'll talk about, because that's one of the sort of nuances or the anomalies there, because enums give us the sense that they're strongly typed, but they're not quite. But just keep in mind that the system is giving us the ability to define a strongly typed interface such that some bad data can be prevented just from the fact that it's strongly typed. And then it will do any validations it needs to do once it receives that data, strongly typed data. But the service interface layer's job is to translate its protocol, in this case HTML or HTTP data, into sort of C# types, if you will, and as strongly typed as it can make it. And if it's a complex type, then of course these complex types could be a little less strongly typed. So loosey-goosey, I use the word loosey-goosey models, versus the domain models are more strongly typed. And in order to convert or map the resource model, which is a loosely typed model, to a domain model, which is a strongly typed model, the service interface layer, or in this case our controller, will map between the resource model and the domain model. And then it would just make a call out to the system. So it doesn't do any business work. It doesn't do any work besides these parts. That's on the way in, as in when the request is come in. Then when the system responds, the system could respond in two ways. One, it could hand the data by way of a domain model back, and it's all okay. And then the controller or the service interface layer will translate that or transpose that in whatever form that is required to send the response back out through the protocol that is working with. So from a user interface perspective, the UI will display the information. From a web API controller perspective, it could be serializing that data using REST or JSON or XML or whatever that it needs to do. But what if the system throws an exception? Then it becomes the service interface layer's job to catch all exceptions and translate the C# exceptions to, again, the protocol that it's working with, in this case HTTP. So it has to somehow translate that C# exception to an HTTP sort of problem, error response. And it might have to map the domain models back to a resource model. So the mapping that the service interface layer is doing is potentially two-way, meaning resource model to domain model on the way in, and on the way back or way out, it'll do the domain model to resource model. And of course also has to catch exceptions or potential exceptions. So let's go jump into the code right now, and then we can go further. So I'm just going to build a simple application here, and this application is going to be a simple, or a certain part of the project is going to be an ASP.NET Core web application, and you're going to pick the API version of that. So we have various choices. We have empty, and we got API, and so on. So I'm going to pick the API version. In this case, is the ASP.NET Core 2.2 version. So you pick that. Now I've already created one, so I won't actually create this here. So I'll cancel out of here, and I'll open up. Well, actually, I don't have it. So I'm not sure why I thought I had it. All right, so I'll create it. Okay, so we've got the basic application here. In case you want to see what we have here is just the basic stuff. There'll be a controller in there called the values controller and a bunch of other things. So I want to change the name of the values controller to movies controller. That's what we're going to be working with today, movies. I'm going to define the models and things for that as well. And it stopped changing this class name also. I'm not sure why. This is 2019. I don't know if it's unique to 2019 now or what. And I also want to change the startup, or what we call the launch settings from here, from this file. That's under the properties folder, the launch settings file, to return or go to API/movies instead of API/values. And there's two profiles. Do it in both places. This way, when we start up our application, is going to go to this endpoint rather than values as I didn't find it. Now, this system in this application is going to be represented by a class called the domain facade. Now, that's all the code that I would write in the domain facade for the sake of the sample is not how I would program normally. So this is not one of the real world kinds of applications in terms of its implementation. So please don't follow these ideas directly or without understanding the fact that this is just a demo application. So I'm going to define now the system in my mind is a whole other thing. It doesn't have to be a separate assembly. We could make it a separate assembly, but I'm also happy in production scenarios also to make it just a folder in the web application itself, because if tomorrow I need to use that somewhere else, then I can break that folder away into a separate assembly and then have it as an assembly. But till I don't have the need, I don't imagine that's what's going to happen. So for now here, I'm just going to add a new folder and call it domain layer. So that's where my system, if you will, starts from. And in this folder, I'm going to create a new class definition for domain facade. Now, this domain facade will have, let's say, a method that gives us movies. This will be an enumerable of a class called movie that we don't have yet. This won't take any arguments. So let's go define the movie. Now I already have the class itself defined. Now this movie class has a bunch of properties such as the name of the movie, the genre of the movie, the year, the image URL, and it's what is known as an immutable type. So once you create an instance of this class, you can never change its properties. The genre, let's go define the genre. This will be a enum. And the attributes are just for display purposes, but essentially these are the genres we have. We have a none, an action, animation, comedy, and so on and so forth. So it's just an enum for all intents and purposes. And the movie class uses this genre, so now this movie class is happy with the genre. And then we'll also have the domain facade implemented here. Now the data for this application is not going to come from a database or a service or something else. So I'm just going to define a public method, a private method on this domain facade. Private static, returning an enumerable of movie. This is just simple code that's creating so many instances of movies and setting up their different properties and their different genres and such like that. So nothing really unusual about. Oh, I guess I already had it. All right. So this is in the domain facade. It's just a way to simulate data coming from somewhere. And so in order to get all movies, we'll have to go get that and return it. So we'll just return the get in-memory movies as part of the get all movies. So that's simple. The next method we'll have here is a way for filtering by genre. So let's implement that. So we'll do the same thing. We'll first get the movies from the in-memory method, and then we'll filter it where the genre is equal to the genre we were provided. So the signature here, the public signature here that you're seeing, this is what I call by strongly typed. This method is not allowing for a string as a genre. It says I need you to give me a genre. So the service interface layer is going to have to make it strongly typed before it can call this method. If this method were to be a string instead of a genre, then the business system would have to go through a bunch of validations and things to make certain that that genre is a valid genre. So in the real world, the validations are required within the business system as well as in the controller, but in this case, we're just going to see it in the service interface layer or the controller layer. So this is the simplistic implementation of these two methods. One gives all movies, one filters them by the genre. And now we're going to flip over to the controller that we had, our movies controller. So I'm just going to change this so it's not confusing. This is not API/values anymore, it's API/movies. And then over here, I should probably go here and create an instance. Again, this is not intended to show you the best practices for production applications, just a quick and dirty application here. And I'm going to change the action result here, and we'll probably use it again, but just for now I just need it to be an enumerable of movie that's being returned. And for that I will return the result of the domain facades method, get all movies. So in this case we have no arguments coming in, and so we can directly just call the system, the domain facade. And what we're going to do now is actually the response from the, so for example, the signature here of the get, let's say it's a movie resource rather than a, so it's a resource model rather than a domain model. Let's assuming the movie is the domain model and movie resource is the resource model. So we can't directly just return the movies. We'll have to map them from movies to movie resource collections. So let's call this variable movies. And we want a function some method that'll map between the movie and the movie resource. And the movie resource will be typically loosely typed a bit. So let's go define in the root project here. Even the folder structure, by the way, is just a clean, quick and dirty application. It's not intended to signify how you should write design applications or the project structures for production applications. And our movie resource looks like this. So in this case, the difference is that the genre property here is a string rather than a genre. and the resource model is not an immutable model. Now, so just to demonstrate that there are differences between the resource model and the domain model. So now that we have this, we're going to need a method in the controller that can map between our domain model, the movie class, and the resource model, which is the movie resource class. So back in the controller, let's define a method here. All right, we don't need all the other endpoints. I'm just going to delete. We'll keep the one. We'll need that for the filter by genre, but we can delete all of these other ones here. And over here, I'll define a private static member that can take a collection of movies and return a collection of movie resource. Right, and it requires a genre parser, so we need to have one of those as well. Let me just hook this up here. So then over here, I can just call the map movie to resource, giving it the movies collection. It's going to return movie resources, so we can return the result of this method. So in this specific method, nothing to harvest from HTTP, and nothing to convert or make strongly typed. Call the system gives you back some data, and you have to then map it on the way out from model to resource model. So now we have this, we need a genre parser here. So I'm going to create the genre parser. Now, the genre parser technically belongs in the domain layer or in the system. So for sanity's sake, I'm going to create it in this folder. And this genre parser is going to be parsing out the string representation of string representation of a genre to a enum and backwards, meaning you can go from string to genre and genre to string. And so it's a bit of a hefty class, but at this point we're not concerned with what and how it's implemented, but it's doing a few other things. So that's our parser. Back in the controller now, we should have this, back in the controller here. So now the controller is happy, everything's working fine. Let's also implement the filter or get movies by genre. Where it takes in this. Now, because unfortunately, the way I don't like some of the stuff that works with ASP.NET MVC or Web API is, especially in the case of genres, the Web API framework can convert a string to a genre if I were to specify the signature to be genre like that. So it will work. My issue with that is when there's a problem, it never came into our application to kind of give us a shot at deciding what the message should be and where's the thing and what the exception type should be and things of that nature. So I'd actually avoid strongly typing it in this case. So I'll actually keep it as a string. So it comes to me as a string, and then I can use my genre parser to strongly type it before I send it into the domain facade. That makes sense. And then over here, this is going to be genre / genre string. So yeah, I'll just change this for. So let's say action as an example. So now, because I've got some data coming in a raw format, a string format, I have to strongly type it. So I'll use this genre parser here to parse. Conveniently, it's got a method called parse that takes in a string, which is the genre string, and it gives us back an actual genre. And then now that we have an actual genre, we can use the domain facade and call the get movies by genre, passing it in the genre. Right? Now this is a bunch of movies, collection of movies. So we'll have to map it from the movie, which is the domain model, to the movie resource, which is the resource model. and then we can return that. It's so far so good. Let's just make sure this whole thing works. There are a few errors. Let's look at the errors and see where we're at. Oh yeah, we're going to change this action to an removal of movie. I'll explain the whole action result thing in a bit. We'll be doing that in this episode as well. Oh, this actually should be movie resource. Okay, so for the happy path, both these methods are implemented. Everything will work fine. Let's just make sure this is going to run. I've still got a few more. Oh yeah, the genre parser. It's got an exception called invalid genre exception. So let me just create a genre exception, invalid genre exception. This will be also in the domain layer. That's our genre exception. Okay, so I'm going to run this application and make sure it's working correctly for both the get all movies as well as the get by genre. So the get all movies is working. You can see there's all these bunches of movies here. And if I were to add the genre / let's say action, we should get our action movies, and you can confirm that from the genre here. They're all action. Let's say we ask for drama, and that works as well. So this is good for the happy path. This is okay. Now what happens if there were an exception? I know the genre parser will throw an exception if it can't find, if the last part here that we gave it, instead of some being a valid genre, is an invalid genre. It's going to throw an exception, that invalid genre exception we just created. So the controller would then have to translate a C# exception into an HTTP like error, and it's going to have to do a bunch of other things with the HTTP response, such as set the status code, set the reason phrase, set the body with the exception message, and in this specific case we'll also set a custom header, exception type header, which will give it the name of the exception that was caught, and that way some client applications can respond to that as well. However we look at it, the job of the controller then becomes to catch all exceptions and then translate or transform these exceptions, the C# exceptions, to something that is HTTP like, because it's talking, the controller or the service interface layer in this case is talking HTTP, so it has to transform that, right? And it's already serializing our movie resource, so it's doing that part, but that's part of the web API framework. It's built in there. The exception part that I'm talking about is something we're going to have to do by ourselves. So let's go look at how that's going to be done. So if I look at the controller, I'm going to simulate. Let's see the problem first. So since it's still running, so instead of drama, let's say I gave it some invalid genre. You're going to see the parser throw an exception, and then eventually the browser is going to show this, and you're going to see line numbers and code, stack traces. Now this is great during production time, but it's not something we want to see. It's great during development time, but it's not something we want to see in production. We want to have a control message, and of course control the HTTP status code, reason phrase, body, and a whole host of things like that. So let's see how we would do that in Web API. So if we go into our controller here, the get movies by genre, this here potentially would throw an exception. So let's implement that. So all of this code will go inside of the try. And it seems to work in the sense that we are returning an enumerable of movie resource, and so that's what we're doing here. But in the case of an exception, unfortunately, we can't return an exception, and they're not compatible. You can't have a method that says I'm returning an enumerable movie resource and then also return an exception sometimes. Not only that, in our case, we want to write to the HTTP response. So we want to talk more HTTP than C#. So we want a means to be able to write to the HTTP response directly here in the case of an exception, so we can alter things about the response. And that's how we communicate back to the calling application, the browser, the service, what is calling us. And that was the action result type that we saw earlier. Now I like this signature because this makes it look very much like a regular C# method. It has nothing to do with HTTP. So I prefer keeping these signatures like this. Today, for the sake of the exercise, we're going to be modifying the signatures to show you how you would use a custom action result. That's a feature in ASP.NET Core as well as the .NET Framework. And then tomorrow we'll look at, not tomorrow, the next time, we'll look at the pipeline and using the pipeline to do the same thing. And then we can revert this signature back to this style and implement what we did today in the pipeline. So that's another feature in ASP.NET Core is the pipeline, and we are going to be creating middleware as one use case. So in that video, of course, I'll explain the whole middleware and the pipeline aspect and how it all works, and then we'll implement a middleware that'll do the same thing, and I'll explain why the benefits or what the pros and cons of both styles are. So here I'm going to change the signature to action result. Of this. So action result, of course, is a built-in type in the Web API framework, and it's the sort of that common type. Is almost like, no, it's not a base class in any form in that sense, but it's like the common way in which you can communicate or respond from a controller, no matter what it is you're communicating, whether it's a serialized object or an exception HTTP response that has something modified. You can communicate that, and we'll now be building our custom action result. So here I would like to have this exception, and I would like to be able to respond with my own custom action that somehow has looked at the exception we just got here, modified the HTTP response message, and then just returned the action result itself. So let's see what that would look like. So this would look like something like return new exception action result. This will be our custom type. And because we'll need the exception in order to help us manipulate the HTTP response, we'll provide it with the exception, so it knows what that exception is, and it'll have the message and other things to construct that HTTP response correctly. Now we don't have this class, so let's go create this class. This class technically belongs in the service interface layer side, not in the domain layer side. So I'll just make sure we create it somewhere in the main application folder. And now this this exception action result has to descend from our action result, which is the base class that's part of the .NET framework. And that's what it looks like. So I'll explain this code here. So this is a descendant of the action result. In our constructor, we ask for the exception so we can use it to better construct the HTTP response. So in our case, in the try catch, we are providing it with the exception as in the constructor, and that's that part. And then, so this is how this works. There's a execute result async method here. So just for now, just remember that's the name of the method, and it's in our action result. I'm going to flip over to the controller again. So, even here I need to change this. Now in Web API, we have some built-in action results that are descendants of action result, and this one is the OK action result. So we need a new OK action result here. And to the OK action results constructor, we pass in the data that we intend to return. And that's as simple as that. So now this method, this part, the try part, is also returning an action result. In this case, it's an OK object result, which is a descendant of action result. And in the exception case, also we are returning an action result. So both ways that signature matches, and that's how this works. Now, what's going to happen here is either this gets returned back to Web API, so back to the Web API framework in ASP.NET, or an instance of this gets returned. The framework, once it gets an instance of an action result, it calls execute action result, or whatever that method was. What is it called? Execute result. So we're not calling it, but the framework calls it after we've returned it. So either of these two cases, either if it gets one of these things back or one of these things back, once it gets that result, the Web API framework will then get that instance and call execute result on it. So it's sort of, it's gone out from out of our control, but then the Web API framework will call that method. So what we're going to do now is, in here, look at this method. This is what's going to happen, and this is where we are manipulating the HTTP response the way we would like it. And I've made it a simpler implementation so you can see what all is done rather than all the things that I would normally do in a production application. Okay, so once we have an HTTP response, we can add to its headers an exception type, which is nothing but the exception that we got, its class name, if you will. That's just in custom HTTP header. It's not necessarily important. I use it quite a bit, but you don't have to have one of those. Then as part of the HTTP protocol, the reason phrase should indicate to the user. So we have things like 200 OK. So OK is the reason phrase, or 400 bad request. That bad request is the reason phrase. So you need to or should manipulate that as part of your HTTP response as well. I've just hard coded it here to say, Houston, we have a problem, but you can have conditionally different values set based on the exception and the message and a whole host of other things. So I'm just keeping it simple here though. And then I'm assuming this bad request could be internal server error, it could be all kinds of different problems. So I'm just hard coding it to be bad request. And so it'll go respond in terms of HTTP is going to be a 400 bad request. And then what I'm writing to the body of the response is the exceptions message itself. So I'm manipulating all the parts that I want to manipulate, but the implementation is very simple. In production applications, it'll be a little more complicated, just a little bit more. So we implemented that. So we look at our controller now, just to go back and explain the whole action result and custom action result aspect of Web API, or both, whether it's .NET Core or .NET Framework, is methods or all of our actions in our controllers can return an action result, and you can descend from action result and create your own custom ones. In the custom action result, you are required to override the execute result or execute result async method. We've overridden the execute result async method in our example here. You're required to override at least one of those, because once you return an instance of your action result, your custom action result, the .NET, the Web API framework will call execute result or execute action and result, and then your code that you wrote there is going to then be called. So it may not be really obvious that's how it's working. So now let's see how this behaves. So we're going to just run it again to make sure it's still working as we expected, and then we'll provide that exception scenario to see what happens there. And this time I'm just going to use Postman, because Postman will show us some of the headers and other information. So I'm just going to use Postman here. I'm going to send this request. We'll see a bunch of movies came back in JSON format. You can see the status code says 200 OK. So this is just part of the HTTP. So this 200 is the status code, and then this OK is the reason phrase. And there are a bunch of headers. So if I look at the response headers here, you'll see that there are a bunch of response headers here that came back from the service such as transfer encoding, content types, server, and the date. We didn't see that correctly. So yeah, X powered by. That thing was X powered by. So these are the headers that the server has sent. Now we know we manipulated the header in our case to add that exception type in the header. We've also changed the status code to a 400, and we've it was bad request, and we said Houston, there's a problem as part of the reason phrase. So let's see how that looks in raw HTTP, almost raw HTTP. So I'm going to say movie / genre / XXXXX. See how that looks. So now what you'll see is, of course, we are seeing the 400 status code that we set up here, but we're also seeing our reason phrase appear here. And if you then look at the body, you should see that the body has the actual exception message that was part of the exception itself. And this exception message is very helpful. As I said, I prefer to control the exception and the messaging and everything myself rather than have Web API do it. And so you can see the genre XXX is not a valid genre. Valid values are none, action, animated, animation, comedy, drama, musical, sci-fi, thriller, so on. So it's very useful information, so you know what the valid values are. But whatever that content is, you can put in there at the time of manipulating the response in your execute action result. And in the headers, we'll see our exception type header that is got the header as well as the type name. So invalid genre exception is the exception we threw in this case. So we've achieved all of the demonstrating all of the roles and responsibilities of a controller. I'm just going to go through them all over again. It's not just a controller. It's any service interface layer that you're working with should do that bare minimum and let the system handle the bulk of the logic, validations, and that sort of thing. So you don't have to repeat the logic and validations outside of the system in the various other service interface layers that you have implemented. So I'm just going quickly through this process. This method actually has some of the features. One, it has to harvest the data from HTTP and convert that to strongly typed C# things. So in this case, we get a genre as a string, and we use our parser to parse that string into a strongly typed genre. And then there's no mapping to be done in this case besides the strong typing, as there's no resource model we're working on the way in. If you were to allow an interface to create a movie, for example, then we would have a movie resource coming in, and then before it could call the domain facades, some method say, create movie, we would have to convert the movie resource to a movie, which is the domain model. But we don't have that option. We don't have that feature here. Then it calls the system. The system returns the movies thing. We map again the movies to movie resource, and we send that out. And so the mapping happened, the strong typing happened with the genre here, and we simply just called the system and said, just do what you need to do here. We don't have to know how it does it, why it does it, whatever. And it also caches exceptions, and it translates our exceptions, C# exceptions, to a HTTP-esque kind of error with status codes and reason phrase and content and headers and stuff like that. So the main purpose of this was, I see this a lot where people stuff a whole lot of code into controllers, and then they're not able to keep the head state as to what kind of code goes where. So that was the purpose of this video. So I hope this has been helpful and you've enjoyed this thing, and I'll see you again for the next video, which is going to be, I don't know if it's going to be the next one, but it's going to be on the middleware, ASP.NET Core middleware, and specifically message handlers, and where we'll implement exception handling there, and so that we can remove it from the controller here, or you can use both. I mean, you don't want to use a mix in the same application. There could be some applications which use this style and some applications use the other style. If you like this video, please give me a thumbs up. Please subscribe. Please hit the notify button, and I will see you next time.